Alright, today we're going to talk about the conversion between coordinate systems. And I'm going to show you this 6-step approach to conversion between two coordinate systems. And so here, let's look at what we have. Here we have kind of two coordinate systems, I and J, ij, and e theta as another coordinate system. And the angle between this coordinate system is given as theta. Theta is the angle here between ER and I. Alright, so the step one is pretty easy. Step one is to identify the coordinate systems. And in this case, we have the first coordinate system, and that is our I and J coordinate system. And the second coordinate system here we have, it's our ER E theta coordinate system. And the second step is to set up the conversion equations for both coordinate systems. And for the first coordinate system, and since the first coordinate system, it's in I and J direction, so I and J are the base of your coordinate systems. So the equation for this coordinate system can be ER equals something I plus something J. And E theta equals similarly something I plus something J. So we have 4 blanks. We don't know what they are. That's a goal of this 6 approach method. We're gonna find out the values of instead of each blank. Okay, so this is the setup for the converging equation for the first coordinate system. And we have the second coordinate system. For the second coordinate system, the base is ER and E theta. So we're going to write I and J in terms of ER and E theta. So we can write I as something ER plus something E theta. J equals something ER plus something E theta. Alright, the goal is to fill out all the blanks right here for both the first coordinate system and second coordinate system. Right, step 3. Step 3, we want to determine the signs for each blank. So we don't know the magnitude or the value for each blank, but we can identify the signs just by looking at the given coordination and angles. Alright, so I will copy this. I will copy my step 2. Duplicate. Okay, let's look at the first coordinate system. If we use I and J at the base, we want to find out what is the signs for both on I component, on the I direction and J direction. Since we have 2 equations here, let's look at the ER first. Okay, if we come back here, look at ER. ER is pointing to this direction, so we can see the I component of ER is on negative direction, right? That's because we define our I is pointing right is positive, J pointing to up is positive. And so we know ER should have a negative I component. How about J components? you can imagine that the j components of ER should also be negative. Therefore, we know ER should have both negative components for I and j. Okay, and do the same deal for E theta. Okay, come back to E theta. Positive on I and negative on j. Positive, negative. All right. And apply the same method for the second coordinate system to decide the signs. Let's look at I first. Remember, in the second coordinate system, we use ER and E theta as the base. So if we look at I has the negative direction compared to the positive ER, but the E theta component of I should be positive, since E theta is pointing to this direction and I is pointing this way, so the E theta components should be positive. So it is negative, positive, negative, positive. All right, now let's look at J. J right here. Let's decompose J on R components, ER direction. You would say it's definitely in the negative direction of ER, and J is also on the negative direction on E theta direction. So J has both negative components in both directions. All right, so far we're done with step 3. We determine the signs for our conversion equations.